What is up, Algebra 2, and welcome to our lesson here, solving systems of equations by substitution and elimination, okay? So again, last lesson, we solved by graphing. These are algebraic methods to solve systems here. The first one is known as the substitution method. Why is it called the substitution method? Well, it's most useful if you have a coefficient solved for, or you have a variable that's already solved for. So if you have a variable that's equal to some other string here. So for number one, we have y solved for as 7x minus 19. What we can do then is substitute it, hence the name, into y right down below. Now a few little tricks here. I like to put it in parentheses. So I'm going to rewrite negative 7x minus 3, the parentheses, and then the 7x minus 19. Okay, parentheses very important because when you distribute the negative 3, you don't want to forget it. And then equals 1, don't forget the end part there. As I distribute, like I mentioned, that's minus 21x. Be careful, lots of little areas to make mistakes. Plus, I'm going to use my calculator I have next to me here, 19 times 3, 57, equals 1. Combine like terms, so negative 28x, going to subtract the 57, and hopefully this stuff is pretty easy to recall from here. And then divide by negative 28. When all said and done, you should have x is equal to 2. And then, you're not done just yet. You also need to find y, Once you have x, you can then substitute it into either one of your originals. I would probably choose the first one because it would be y is equal to 7 times 2 minus 19. 14 minus 19 is simply negative 5. And that is it there. Now, if you want to know how to check your answers, you can always substitute your variables with your solutions here. So I'm highlighting them because if you plug them in for x and y in each equation, it has to work for them both. So it's an easy way to check your work is to substitute back to check. I always recommend doing that, 7 times 2 is 14, minus 19 is negative 5. Negative 7 times 2 minus 3 times negative 5 in the calculator is 1. So that works out. Number 2 here, so just the second equation is solved for y. And it might not always be y, it might be x, but it's the same process. So we're just going to plug it in for y there. Negative 5x plus 6 times 4x plus 14 equals negative 11. Negative 5x plus 24x, 6 times 14 is 84. Negative 11. Boop, boop. And shake and bake, 19x. Subtract the 84. Negative 11 minus 84. Going too quick, of course, you can always kind of rewind to go slower. But hopefully this step is all pretty trivial. So x is negative 5. Going to need to plug it back in. Going to use the second equation. 4 times negative 5 plus 14 is going to be negative 20 plus 14 is negative 6. X equals negative 5, y equals negative 6. Hopefully you're getting the hang of it here then. Number 3. Oh man, this is a exceptionally easy one. Y equals 5. Just plug it on in. Negative 12x plus 9 times 5 equals 33. You're like, wow, that was super duper easy. 45. 33 minus 45, negative 12, equals negative 12x. And subtract. And x equals 1. So x equals 1. Y they already gave you is 5. How about that? Nice and easy. Okay, number 4, if you want to try it on your own, you can pause and go for it. But I will certainly work through it now. Negative 3x minus negative 3x minus 11. A little funky looking here, so just, it could be helpful to kind of label everything as to what you're plugging in. Okay, distributing a negative 1 is 3x plus 11 equals 10. Here's a trick question, I suppose. Negative 3x plus 3x is 0x plus 11 equals 10. I have the expression 11 equals 10. That is never true. Not true. Thus, there is no solution. Okay, so if you're left with an expression that is not equal to one another, then it's not true. On the flip side, so versus, if you have something 0 equals 0, that is always true, which is infinite solutions. And a lot of this should be a little bit of review here. Let me just double check everything here. Substituting in the negative, okay, and in for y. And I believe that is the case. Okay, so that's substitution method. Technically, that's lesson 3.2. 3.3 here is on elimination. The elimination method is most useful when you don't have that solved for coefficient. And the key with it is to make opposite coefficients by multiplying an equation, or both. Okay, so when we look at number 5 here, it can be helpful to first decide which variable is going to be easiest to eliminate. And you look for ones that are factors of one another. So I noticed that 5 and 10, they are factors of one another, okay? Or they multiply to each other. So I can easily make a 5 into its opposite of 10 if I multiply the entire top equation by 2. Now when you do that, just be careful, you need to distribute to everything. So I'm going to rewrite this top equation that I multiplied by 2. So it's going to be 10x plus 18y equals 12. Okay, now that that is done, you can add the one I didn't change, okay, and the new one. So you can almost imagine this is kind of dashed out. Okay, now these new ones, it's called elimination method because the negative 10 and the 10, they become 0 or they terminate. Okay, negative 6 and 18 is going to give us 12. And then don't forget to add these numbers at the end. Negative 24 and 12 is negative 12, and that's a y. Y by 12 means y equals negative 1. Now, just like before, we still need to solve for x. Okay, x equals, And you can solve for that by now substituting back into either one of the original equations, okay? You can certainly choose the first one, so that's why I didn't want to cross it out too much. So if I take 5x plus 9 times -1 equals 6, I have 5x minus 9 equals 6. 15 equals 5x, and x equals 3. Okay, same idea as before. 3, -1 is technically the coordinate point. You can check your work, but that's the name of the game. So a little bit of an easier elimination there. Use the factors to multiply. Okay, looking at number 6. We have the same idea, a similar idea here. So y and x, they could each go into one another. Let's multiply the bottom equation by 2. So you can multiply either equation. What that will do for us is make it -10 x minus 8y equals 18. And hey, we have the same thing in the numerator. Would you look at that? Okay, something else we can do, so let's just continue on here as though that didn't happen. Let's multiply this by a -1. Okay, that's going to change all my signs. And then when I add, you'll see that everything cancels out. Okay, so essentially I have 0 equals 0, which I discussed above, is infinite solutions. Okay, so if you have two equations that's a scale of one another, they're all exactly the same, each part, all three, that just means typically there's going to be infinite solutions. Okay, so just be aware of that as well. No solutions, infinite solutions. Sometimes, again, you may end up with 0 equals 5. Okay, that's not true. That would be no solutions. Okay, so just remember that off to the side. Let's go through a few more here. Okay, 7. Now 7, if you look at it, 3 and 2, they are not really factors of one another, nor is 7 and -3. So what I always like to do in this case is just pick the 7 maybe and the -3 and just multiply the other equation by that coefficient. So I'm going to multiply the top by a -3 and the bottom by 7. Okay, actually the top by a +3, and you'll see that there. Okay, you want to keep the signs opposite. Now what that will do is make this into 21x positive plus 9y equals 18. Down below, so it's all about organization with these. -21x, that's why I didn't want the negative up top, minus 14y equals 7. The 21x and the -21x terminate. Okay, 9 and -14 is -5y, and then we are adding these two, 18 and 7, which is a nice 25. Okay, we'll divide by -5. That gives us y is equal to -5. And then we can again substitute into any of the originals. We have to find x. So I'll use the first equation, 7x plus 3 times -5 is equal to 6. So 7x minus 15 equals 6. Going to add that 15 over. That's 21 and then divided by 7, x equals 3. So our coordinate point is 3, negative 5. Okay? So multiplying both equations by that there. You could also have chosen 3 for the bottom and 2 for the top. Really, there's more than one option for you. Okay, number 8. So another one, we're going to have to multiply both things here. So whatever you're thinking, maybe try it out on your own here. I am going to go with, okay, 9 and 2. Multiply top by 9 and the bottom by 2. Top by 9, we'll make a negative 9. I want them to be opposite signs. So that gives me 18x minus 36y is equal to 0. Okay. Sometimes it can be helpful to label them so you know which equation's which. Okay. That's negative 18x plus 20y is equal to negative 32. Okay. X's cancel. Negative 16y is equal to negative 32. So then y is equal to 2. Plug it in, got to find x. Use the first equation. Negative 2x plus 4 times 2 equals 0. Subtracting 8 to the other side. And then dividing. So x equals positive 4. Just remember, coordinate points always go x, y. So if you're writing your answer like that, please write it properly. So 4, 2. Okay, now that's the elimination method. Substitution, elimination. Okay, so that's a great job on those. I am also going to, so feel free to pause here, do some practice, but I'm going to move on to the word problems of these as well. So word problems are on the next page, but feel free to pause and to come back later. Our word problems, okay, are going to all involve systems of equations. So systems word problems. And really, it's all about the setup. You have to set them up properly. You're going to have 2 equations. Okay? Toxacan and Jose. I don't know if I said that right, but we'll go with that. Each improved their yards by planting daylilies and ornamental grass. They bought their supplies from the same store. Toxacan spent $47 on 4 daylilies and 1 bunch of ornamental grass. Jose spent $274 on 17 daylilies and 11 bunches of ornamental grass. Find the cost of 1 daylily and the cost of 1 bunch of grass. Okay, what I always like to do, because the wording and everything can be confusing, is decide what variables to represent. So think about what is being asked of you. Find the cost of 1 daylily. Well, let's let daylilies, daylily, we'll let that be x. Okay, cost of 1 bunch of grass, we'll let the grass be y. Once you have that, you can kind of go back through the problem and replace things in terms of x and y, okay? So $47 on 4 daylilies. I know daylilies is x. And 1 bunch of grass, that's y. Next up is $274, 17 daylilies, x. And 11 bunches of grass, y. And let's just look at the 2 other bits that we have. So I know that 4x plus 1y equaled Tosakan's total of 47. In the second equation, I know that 17x plus 11y equaled Jose's total. So find your variables, plug them into the words, and usually all the information in one is going to be a part of the other. Once you have it set up, it's as easy as using substitution or elimination, but the setup can be the hardest part here. Okay, you can use substitution, you can use elimination. What I will do with this one is multiply the top by 11. Okay, that will make, actually I'll multiply by negative 11 in order to make it negative 44x minus 11y is equal to 47 times negative 11, negative 517. From here, my y's will cancel. 274 minus 517 is negative 243. 17 minus 44 is negative 27x. And then I'm going to divide and get x is equal to 9. Alright, now we also have to find y. So y is equal to, and you just plug that back in, 4 times 9 plus 1y is equal to 47. So that's 36 plus 1y equals 47. 47 minus 36, 11 equals 1y, which just means y is equal to 11. Now, as you answer word problems, make sure you use your units. So I know that x are daylilies, and they cost $9 each. Ornamental grass, what is ornamental grass? I might have to look that up later. Costs $11 per bundle. Okay, so setting up those problems is the most challenging. Let's look at another one here. The school that Molly goes to is selling tickets to a play. On the first day, the ticket sales in the school sold 11 adult tickets, 15 students for a total of $199. School took in $247 on the second, 17, and 3 students. Find the price of an adult. So adults will let be X, and students will let be Y. And it's very similar to the one above. So we have day 1, 11 adults plus 15 students is equal to, you can use A and S even. You can use the variables that sound like the words. Okay? No rule against that. So adult be A, students be S. We'll do it that way. Is equal to 199. So make math, I mean, don't be so afraid of it. Tweak it. Make it a little more fun for yourself, or just make it so it makes sense to you. School took in $247 from 17 adult and 3 students. Once you have that set up, then you can go about and multiplying. So we're going to have to multiply both equations here. I'll choose a negative 3 up top and a positive 15 on the bottom. So it's going to be negative 33a minus 45s is equal to 199 times negative 3, negative 5, 97. On the bottom, 17 times 15 is 255. 15 times 3, which will be our positive 45. And 247 times 15 is 3,705. Okay, numbers are bigger, don't let them scare you. S's cancel. 255 minus 33 is 222. And that's going to be equal to negative 597 plus 3705, 3108. And we're just going to divide that. And fortunately, that comes out to be a nice answer for us. So A equals 14. That means 11 times 14 must be plus S is equal to 199. 154 plus 15S equals 199. And subtracting the 154, 15S is equal to 45, and students then would cost, divided by 15, $3. Okay, so adult tickets are $14 a piece, and students are $3 a piece. Bada bing. All right, so the grand finale. So these are one of the most challenging problems to think of just because the wording's a little tricky. So flying with the wind. A plane went 365 kilometers per hour, flying into the same wind. So you could think of flying against the wind. The plane only went 319. Find the speed of the wind and the speed of the plane. So this is similar if you ever go running and you know, like if you're running with the wind, that's easier. And if you're running against the wind, it's harder. So here's our equation with the wind. Okay, well, let's think here. So first off, let the speed of the wind and speed of the plane. So speed of the wind will let be x, and speed of the plane will let be y. If you're with the wind, okay, and you're traveling, you have the wind's speed working with you, and you also have the plane's speed. So you have both of those speeds that are contributing, in this case, to 365. Against the wind, or into the wind, you are traveling against the speed of the wind. So it's going to be minus x for the wind speed. You just have the speed of the plane. Okay? And we know that's equal to 319. So if you have that set up, and I know it's jumping here, but we're almost finished. If you have that set up, it's pretty easy actually from here. With the speed of the wind and against are going to cancel out. Now be careful. We have y plus y, which is 2y, and that's going to equal 365 plus 319, 684. Okay, if we divide by 2, that means that y, or the plane speed, is equal to 342. Well, with that found, you can then substitute into one of the originals. Either one works. And I know it's getting bad, but just hang in there. The speed of the wind plus 342 is equal to 365. Subtract 342. 365 minus 342 is 23. And that's the wind speed, kilometers per hour. Sorry about it getting so jumpy here, but that is essentially how to set those up. Hopefully you can see them. And great job, guys. Practice all that stuff and have a great rest of your day.